Building an LVM is actually one of the most straightforward things that you can do when it comes to block storage devices on Linux. It's surprisingly consistent all the way through the process for the names of the tools, and it really is kind of fun. And once it's built, you can expand it by adding more drives to the system, or stretching your existing volumes. But let's go ahead and actually create from start to finish an LVM system on our Linux device. Now here I am on Ubuntu, and if we do lsblk, we're going to see that, well, we have a bunch of stuff. But down here, this is the drive that our system is installed on. So we're not going to touch this one. We're going to use these four devices. So SDB, C, D, and E, which are 10 gigabyte devices. Notice I don't have partitions created on these. Now you can create partitions. Some people prefer to use partitions for their physical volumes in an LVM. Some people prefer to use the raw devices. Either one works fine. They work the same. The advantage of setting up a partition is that if somebody else comes to your system, they're going to see that there's partitions on the system, and they're going to know that something is already done there. Whereas if you leave them raw devices, they might think, oh, look, empty drives. Now, it's kind of far-fetched. You're not just going to start formatting drives in somebody's system, but that's the reason some people like to use partitions. I'm just going to use the raw devices. And to turn these raw devices into physical volumes, we use pv create, and we just make a list of the devices we want to use. So dev SDB, dev SDC, dev SDD, and dev SDE. So it created them. Now we can do pv display if we want, and it's going to show all the devices that we have. Now each of them is 10 gigabytes, and the name of it is just the device itself, dev SDC. So the next step is to create a volume group. Now to do that, we just do VG create, which is very, very nice. The first flag, or the first command argument here, is the name of the volume group. So I'm going to call this bucket, because it's just a big bucket of our hard drives, right? Of our data that's available. So I'm going to call the volume group bucket, and then we just make a list of the physical volumes that we want to add to it. So those same volumes we just did before. And then press enter. Our volume group bucket was created. We can look at that by doing VG display. There's 4 metadata areas, meaning we have 4 devices. Our current active PV are 4. We have 40 gigabytes of storage just about all together, because each one was 10. And now we have this thing called bucket that we can carve a slice out of if we want, and use that slice and put a file system on it. So to do that, we're going to use, I'm sure you guessed it, LV create. I love the consistency of these tools. It's really nice. Here we do -L and how big of a slice we want. In this case, let's do something that's going to span all 4 disks. So I'm going to say 32 G for 32 gigabytes. And then -N, the name that I want to call it, I'm going to call this big underscore slice. And then we have to tell it where we want to get the data from. Well, in our case, it's in bucket. The name of our volume group right there is bucket. So what we're doing is creating a 32 gigabyte slice called big slice out of the volume group bucket. Press enter. Logical volume big slice is created. So we can do LV display. And sure enough, LV size is 32 gigabytes. So we know that that worked. The name is big slice. It's in bucket. The LV path is dev bucket big slice, which is exactly what we would expect, because we've created this volume group called bucket, and now this logical volume lives inside there. So the last step is that we would actually use this as an actual block device, or as a hard drive in and of itself. And then we could just do something like mkfs ext4 dev bucket big slice. And there we go. So now we've done that. We could mount it somewhere, and every time the system starts, it's going to be available in dev bucket big slice. And then if we put it in fs tab, it's going to be mounted on boot. And then there are other tools that we can go and, like LV extend, if we wanted to make it bigger. So we could do something like LV extend -L. I'm going to say plus 5 gigs dev bucket big slice. And now it says the size has gone from 32 gigabytes to 37 gigabytes. It was resized. And we did that without adding anything to the system. We just used the tools to change the size of our logical volume. The thing to remember again about LVM is that it provides flexibility in your system. It doesn't provide any redundancy. So if you have one physical volume fail, it's going to crash the entire volume group, and logical volumes are going to get messed up. So you want those PVs to be like a RAID device if you're worried about something going wrong underneath and losing data. But setting up LVM, as you can tell, is very simple, and honestly, even kind of fun. I hope this has been informative for you, and I'd like to thank you for viewing.